Our project deals also with pressure on forests, but more within forest area. It deals with sustainable ecosystem services in Swiss forests. Our project is a collaboration of people from WSL, so myself, Brigitte Rohner, Golo Stadelmann, Christian Temperlin, Jürgen Zell, and Oliver Thees. And then we have a collaboration with the Federal Office of Environment, FÖN, and with ETHZ, so this is Harald Buchmann. Forests provide many ecosystem services. In the NFI, we surveyed the main service, and that's what you see here. So, in the flatland, it's mainly the main service is wood production. In the alpine areas, we have at the moment, it is protection against natural hazards, and scattered all over Switzerland, we have recreation mentioned as the main service. However, forests are more complex than one main service, so in most cases, forests provide multiple services. And global trends provoke challenges in sustainable provision of ecosystem services. So this is climate change, to be mentioned, or energy change. And as forests are slow systems, we cannot do just an experiment and look what happens in 50 years. So models, forest simulation models, allow us to quantify ecological or economic effects or over long time periods. So to have a look into the future and to have if-then-else scenarios, we work in this project with two different forest models. One is called Massimo. It's based on the Swiss National Forest Inventory data. This is an example of one of the 6,000 plots that are scattered all over Switzerland on a regular grid. So we have here an empirical forest growth model that is representative for a regional to a national scale all over Switzerland. This model has been already applied for the Swiss greenhouse gas inventory and for estimations of the Swiss harvesting potential. However, it is not a real stand model, and we are now interested in stand management. So we worked with another second model, it's called the Swiss Stand Sim, and this model is now derived from data that come from the experimental forest management plots, and those plots normally are around 1 hectare and represent real stands over long time periods. So we have with the second model, again, a single tree-based model, but this time it's a stand-based model, as it represents real stands. We have long time series, and therefore it is empirically climate sensitive. However, it is not representative for Switzerland, and that's what finally we are interested in. So we have here a missing link between the stand model and the national representative model. So our milestones we would like to achieve are as follows. First, we start with the national inventory data, and we classify those data for forest types. We then define, together with decision makers, we define scenarios, and we simulate those scenarios using the stand model Swiss Stand Sim. As a next step, we assess the results, the model results for different ecosystem services. And these steps 2 to 4 are done iteratively. So we go back with the results to the decision maker and redefine the scenarios according to their needs. We plan to have about 3 workshops with the decision makers. With the result we get then, we plan to develop a tool, a decision support system, a prototype of such a decision support system. Then we scale up the results to get the national representativity using Massimo. And as a last step, we compare then the 2 models and see what are the effects of scale which are important. So what do we learn from this project? In scientific terms, we get climate sensitivity for both models in terms of growth, mortality, and regeneration. And we will be able to assess the effect of climate change on ecosystem service provision. And as an important term, these scaling effects. It does make a difference if we look at ecosystem services of a stand, of a landscape, or the whole nation. In practical terms, or for outreach, we will develop sustainable forest management strategies together with decision makers. And we will also evaluate those strategies in terms of different ecosystem services and their positive and negative interactions. And as a last thing, we will develop an IT-based decision support system for practitioners and test this in case studies.